Hello everyone, this is my kaggle assignment 3. I have run the first cell to find the file links for the files, and then I have done the necessary imports for the entire notebook. Now I'm going to load the data frames, the test data frame, the train data frame, and the sample submission using the links that I have obtained previously. And now taking a look at the train data frame, we can see that it has 7000 rows and 26 columns. The last column is a target column, which is the class, which has two values, which is P and E, where P refers to poisonous mushroom and E refers to edible mushroom. In the test data frame, we have 25 columns. It's because we don't have the last column, which is class, because we are supposed to predict it. Now in the dummy classifier, we can I have taken the dummy classifier and fit it on the train data frame and predict it on the test data frame, and I can find the accuracy score. So we can see that the sample submission file that we have been given was also trained by the dummy classifier, which is why the number of wrong predictions is 0. Now coming to data types, I have used .info to find the different data types that are present, and to check if there are any null values. So we can see that there are there is one float column. There are 3 integer columns and 22 object columns. We also have a few columns where there are non-null values. So we basically have 4, such as ring number and ring type, etc. Now in train data frame, I'm going to drop the ID column because it's not really very useful in the descriptive statistics, and then in the descriptive statistics and here on. So when I perform the descriptive statistics on the numerical columns, I can find values such as the count, the mean, the standard deviation, the minimum, the quantiles, and the maximum of the numerical columns, which are number of cruises and ring number. Though ring number, we can see that it has two values, 1 and 2, but the mean is 1.08 and not 1.5, which shows class imbalance. Also there are null values in the column ring number, which is why the count is not 7000. Now if I take, we can find the number of mushrooms that we are taking a look at in this data frame by using value counts, and we find that there are 7000 unique mushrooms that whose data is in the train data frame. Coming to the categorical features, we first select all the features whose data type is an object, and we find the number of such features, and it turns out to be 22 such categorical features, and this is the name of the columns of those categorical features which we have used in the categorical columns. And we have obtained the number of unique categories in these categorical columns using value counts, as well as the NaN values if there are any. So this distribution is for cap shape, which has no null values. This is for cap surface, which also has no null values. This is for cap color with no null values. This is for bruises with no null values. This is for odor, which is having null values, 3236 null values. This is gill attachment, which has 2 columns with a very high class imbalance and no null values. And then in gill spacing, we again do not have any null values. In gill size also we do not have any null values. In gill color, there are again no null values. In stock shape, we can find the distribution of the two columns, and in stock root we have null values again. And then in stock surface bow ring, we have no null values. In stock surface below ring, we again have no null values. This is stock color above ring, stock color below ring, and wheel type, which has only one class, so we are going to remove this column. The same follows for wheel color, and a ring type has 36 null values, and this is the class distribution of that column. And this is for score print color, and this is for population. The next one is for habitat, and the next one is for class. So we dropped wheel type and wheel color because there was only one value in all of the columns. Now if we look at we already took a look at the NaN values, and this is a brief about the sum at once. And then we have taken a heat map to find about the correlation between the numerical features, and we find that there is no particular correlation between them, which was the result that we wanted. And duplicates, to find the number of duplicates, and we find that there are no duplicates. Then if we use the standard procedure to find the number of outliers and find the number of outliers, then it shows that we have like 564 outliers, but they are really not an outlier, because the outlier value is found to be 2, and we need to keep it because it's actually a category, even if it's a numerical column. And then visualization of histogram plots for number of bruises, ring number. And then we have counts, which is we have this bar graph for cap surface versus cap shape, which is the distribution of cap shapes by surfaces. And we see that most of the cap surfaces are scaly, and a lot of them are shaped as convex. And then this is the habitat distribution in the train data set, which has widths, grasses, and paths. And then in the feature engineering column, we have used stratified shuffle split to split the data set into train set and validation set, because of the heavy class imbalances which we observed previously. And then we drop mushroom ID, because it's not really that useful in model building or model to like train a model on it using mushroom ID, so we just drop it. And then we divide it into X train and Y train and X val and Y val, and these are the shapes. And this is how Y train looks like, and this is how X train looks like. So next we find there are null values which we found previously. Now so to deal with that null values, we impute in all the columns which are null values, and we find the numerical and categorical columns, so that we can encode all the categorical columns and scale. In the numerical columns we had these numerical columns, so we use the same numerical columns over here. So instead of this, we could have just added numerical columns. So this was numerical columns that we used for scaling, and then pipeline with imputer, encoder, and scalar. So this is the pipeline, and then we fit transform on explain and transform on validation set, and then use a label encoder for the y train and y val. And this is how explain transform looks like, and this is how y train transform looks like. Now we are doing model building, so I'm using 7 different models. I'm using random classifier, gradient boosting classifier, I'm using random forest classifier, I'm using gradient boosting classifier, session tree classifier, k-neighbors classifier, Bernoulli naive Bayes, logistic regression, and SVC. And I fitted each one of them on the train, and found the accuracy score on the validation. and turns out for most of them the value is 1. Decision tree comes close to 0.98, and naive the accuracy score is 0.89, so which is approximately zero point 0.9. And this is the plot comparing all the model performances. Now because for most of them we got 1, we are going to check for overfitting. So I found the confusion matrix, and we can find that there are no wrong predictions when I used the confusion matrix on all 5 of the models on which we got the score as 1. And then we check for feature importance to check if they are giving any high feature importance for one particular feature, and turns out it's not really the case. And when we use gradient boosting, it shows that for stock surface evaluating, it gives like a lot of importance to one feature, so maybe this could be a case of overfitting. We move to hyperparameter tuning by using the param grid and grid search CV, and find the scores and the parameters for a random forest classifier. We had best score as 1, and these are the best params. For gradient boosting, again 1 with this best params, and for KNN also 1 with this best params. For linear regression, again 1 with this as the best params. For SVC, which is from SVM, we again have 1 as the value, so we can take any one of them. So this is test data frame which we took a look at the start. Now we can drop the values, because we did not use these values in while we were considering for trained data frame, while we were training the models on trained data frame. So we can drop it and transform on test data frame, and this is how the transformed data frame looks like. And we can take any one of the hyper-tuned models to predict on this data frame and submit it. Thank you.